friends, welcome back to our channel. In earlier videos, we have discussed about the problems on maxima and minima of a function with two variables. In this video, I will explain one more example on maxima and minima. See the statement of the given problem. Find the maxima and minima of the function x³y² whole into 1 minus x minus y. This problem is very important problem in both JNTU Kakinada and JNTU Hyderabad universities and their affiliated colleges. So please listen carefully. So here already in earlier videos we discussed about the procedure how to find the maximum and minimum of a function with the two variables. If you didn't see that video, once please see that video. Okay. First of all, let us represent the given function with the f of x comma y. Let f of x comma y is equal to x³y² whole into 1 minus x minus y. For our convenience, take this term to inside. So f of xy can be written as x³y² into 1, x³y², x³ into x. It would be x⁴ y² minus x³ into y² into y. So y² into y is y³. Now, first of all, we have to find out the both first order and second order partial derivatives of the given function. Okay, already you know that the first order and second order partial derivatives are represented by p, q, r, s, t. So first of all we have to calculate p value, next q value, next r, s and t. We have to find out these all things. What is p? P is nothing but dou f by dou x. It means that we have to take the partial derivative of this given function with respect to x. Whenever we are taking the partial derivative with respect to x, except x remaining are all constants. Particularly, y terms becomes constants. Here, in the first part of the function, y² is constant. So, don't disturb that term. Just take the derivative of x³ with respect to x. It would be 3x² y². Okay? Minus, here also y² is constant term. Just write the partial derivative of x⁴ with respect to x. It would be 4x³ Already you know that derivative of x⁴ is 4x³ y² minus, here also take the derivative of x³ only. Here y terms are in product. Whenever y terms are in product, they were constants. So don't disturb that terms. 3x² y³. Okay. Now what is q? Dou f by dou y. Here, except y, remaining are all constants. Particularly whenever you are taking the partial derivative of a function with respect to y, x will be constant. So this time take the derivative for y². y² is, derivative of y² is 2y. So x³ is the similar term. 2x³ y minus, here also y² is the variable. Derivative, take the derivative of y² with respect to y. It would be 2y. Already x⁴ is there. That's why I am writing as 2x⁴ y minus derivative of y³ is 3y². Okay. So already many times I said you, for engineering mathematics, knowledge of partial differentiation and integrations are very important. So next, what is our second order partial derivative of f with respect to x? It would be dou square f by dou x². Okay. Already first derivative is here, which is dou f by dou x. So you can take one more derivative with respect to x here. So derivative of x² is 2x, already 3 is there. So 6xy² minus derivative of x³ is 3 4s are 12. 12x² y². y² is constant term which is in product. That's why I don't want to disturb this term. Okay. Minus, again derivative of x² is 2 3 6. 6x y³ Okay. Now what is s? Dou square f by dou x dou y. This means that we can write this term as dou by dou x of dou f by dou y. I hope you all understand this step. Okay. Here what is dou f by dou y? It is q. So for q term you have to take with respect to x partial derivative. Here also x is only variable, y is constant. So derivative of x cube is 3 2s are 6 x square y minus derivative of x power 4 is 4 2s are 8 x cube y minus derivative of x cube is 3x square, 3 3s are 9 x square y square. Okay, I hope you all understand these are partial derivatives. Now finally it is t. Dou square f by dou y square, second order partial derivative of f with respect to y. Already first order partial derivative is here. For this term we have to take one more derivative with respect to y. In this case only y is the variable. So just take the derivatives for y with respect to y only. Derivative of y with respect to y is 1. 2x cube into 1 is 2x cube. Minus, here also y is there. Y derivative of y with respect to y is only 1. It is 2x power 4. Finally it is derivative of y square is 2y. Already 3 is there. That's why directly I am writing as 2 3s are 6x cube y. So calculating partial derivatives. First order, these both are first order partial derivatives. These 3 are second order partial derivatives. So evaluating these partial derivatives are very important. Okay. Already you know that we can get the maxima and minima of a function. Function is nothing but it represents a curve in the two-dimensional system. So that curve has maximum otherwise minimum at the stationary points only. So at that stationary points slopes of the given curve should be 0. So what is the mean by slopes? First order partial derivatives. So for getting maxima and minima we should find out the stationary points. For that stationary points we should take first order partial derivatives to 0. Okay, don't forget that one. So for maxima and minima, for maxima and minima we should take slopes should be 0. Slopes means first order partial derivatives. Okay, I hope you all understand this. So what is p? I will write here. What is p first order derivative? 3x square y square minus 4x cube y square minus 3x square y cube is equal to 0. Okay. So also we have to take q is equal to 0. What is q? 2x cube y is there minus 2x power 4 y minus 3x cube y square is equal to 0. Okay, so we have to solve these both equations now. Clearly here we are observing that from the first equation every part has minimum x square as common term and every part has 1 y square is the common term. So x square y square is the common term in the first equation. So 3 is the remaining term in the first part minus, so 4 is there. If you take common out the term x square from x cube, x is the remaining term, y square went outside minus here x square goes outside and 1y will be there. So it is 3y is equal to 0. In the similar way, observe the second equation. All terms has minimum of 1y, okay, and minimum of 1 x cube term. This is x cube, okay. So x cube y is the common term. So you will get remaining term is only constant term is there in the first part minus 2 into 1x is remaining minus 1y is remaining, 3 is also there. Okay, so here we are observing that x is equal to 0 and y is equal to 0 and this factor is also 0. Here also x is equal to 0, y is equal to 0, this factor is also 0. But here I am eliminating 0, 0. From this we are observing that 0, 0 is a stationary point. But it is not necessary to take 0, 0 as a stationary point. Because if you take 0, 0 as a stationary point, we have to find out the RST values at 0, 0 also. We are observing that in RST, every term has xy. Every term has x and y. If you replace x is equal to 0, y is equal to 0, in RST, R value becomes 0, S value becomes 0, T value also becomes 0. So automatically RT minus S square also becomes to 0. That's why if RT minus S square is equal to 0, we can't decide the conclusion. That's why you can eliminate, you can remove 0, 0. Better to don't take 0, 0 as a stationary point whenever RST has xy terms in each and every term. Okay, so directly you can send them to right side. 0 by anything 0. Simply we have 3 minus 4x minus 3y is equal to 0, and you can send this both terms to right side denominator. 0 by anything 0. 2 minus 2x minus 3y is equal to 0. So by rearranging the terms, you will get 4x minus 3y is equal to 3. Just I am taking this both negative terms to right side. So you will get 4x plus 3y. 4x plus 3y is equal to 3. Here also you can take this negative terms to right side. You will get 2x plus 3y is equal to 2. Okay, I hope you are understand now. Take it equation numbers 2 and 3. Just you can subtract them. We have to solve these both equations. For that purpose I am taking the subtraction of both equations, because I observed that in both equations y terms are same. That's why 4x minus 2x, you will get 2x. 3y minus 3y gets cancelled. In the right side 3 minus 2, it would be 1. So what is x value? X value is 1 by 2. X value is 1 by 2. You can substitute this x is equal to 1 by 2 in the equation number 3. Substitute in 3. So you will get 2 times of what is x? It is 1 by 2 plus 3 into y. We are going to find out y value now. This 2 gets cancelled. 1 is the remaining term. If you take this one to right side, you will get 2 minus 1, 1. So 3y is equal to 1. So finally you conclude that y is equal to 1 by 3. Okay. Now you should conclude that 1 by 2 comma 1 by 3 is the stationary point. Is the stationary point. Now we have to find out R, S, T values at the stationary point. It means that you have to substitute 1 by 2 comma 1 by 3 in both in all R, S, T. Okay, please see. Now we have to substitute this 1 by 2 comma 1 by 3 stationary point in RST. So at 1 by 2 comma 1 by 3, at 1 by 2 comma 1 by 3, what is R value? Whenever we have x, replace it by 1 by 2. Whenever we have y, replace it by 1 by 3. So 6 into x means 1 by 2. Y square, so 1 by 3 square, directly you can write as 1 by 9 minus 12 into 1 by 4, y square means 1 by 3 square, it would be 1 by 9 minus 6 into 1 by 2 into 1 by 3 cube means 1 by 27. Okay, 3 cube means 27. So this 2 gets 3 times and this 3 gets 3 times here. So however you have only 1 minus this 4 gets 3 times, this 3 gets 3 times. So you will get first term is not only 1, numerator is 1, denominator is 1 by 3. Minus here also you will have 1 by 3. minus this 2 gets 3 times and this 3 gets 9 times. Minus sign is there, minus 1 by 9. 1 by 3 and 1 by 3 gets cancelled. So R value at the stationary point is minus 1 by 9. We are observed that it is negative. Now we have to find out S value also. See here. 6 into, what is x square? It is 1 by 4. Okay. What is y? It is 1 by 3. Minus 8 into 1 by 2 cube means 1 by 8. Y means 1 by 3. Minus 9 into 1 by 2 square. It would be 1 by 4. And y square means 1 by 9. So 8 gets cancelled here. This 3 gets cancelled 2 times and 2 gets 2 times here. So you will have 1 by 2 is the first term, minus 1 by 3 is the second term, and 9 gets cancelled. So you will have 1 by 4. So take the LCM. For 2, 3, 4, 12 is the LCM. 2 gets cancelled 12, 6 times, that's why it is 6. 3 gets cancelled 4 times, that's why it is 4, and it is 3 times. So 6 minus 7, minus 1 by 12. S value is minus 1 by 12. In the similar way, we have to find out T value now. See, 2 into x cube. X means 1 by 2. So it would be 1 by 8. Minus 2 into 1 by x power 4. So 1 by 2 power 4. It is 16. Minus 6 into 1 by 8 into 1 by 3. So this 2 gets cancelled 4 times and this 2 gets cancelled 8 times, 2 times, and 2 gets 4 times. Simple calculation. So 1 by 4 minus 1 by 8 and this is minus 1 by 4. So 1 by 4 minus 1 by 4 gets cancelled. So you will get minus 1 by 8. So R value is minus 1 by 9, S value is minus 1 by 12, T value is minus 1 by 8. Now we have to evaluate RT minus S square also. See. Therefore, RT minus S square at the stationary point becomes minus 1 by 9 into minus 1 by 8. Minus minus plus 1 by 9 into 1 by 8. 9 8s are 72 is the denominator. 1 by 72. Minus minus 1 by 12 whole square means it becomes positive, already negative sign is there. 12 square means 144. What is the LCM for 72 and 144? 144 is the LCM. 72 gets cancelled twice in the 144. So you will write 2 in the numerator and 1 is there. So it is 1 by 144. So it is positive. So what is our investigation here? We are observing that RT minus S square is positive and R is negative. So our function has minimum. F of x comma y has minimum at a stationary point. At the stationary point, what is the stationary point in this problem? 1 by 2, 1 by 3. So we have to find, extremely sorry. So whenever RT minus S square is positive and R is negative, you should observe that f of x comma y has maximum. Don't forget it. Okay, don't write in opposite way. Okay, has maximum at 1 by 2 comma 1 by 3. So you can substitute this 1 by 2 comma 1 by 3 in the given function. So you will get that maximum value. So what is it? F suffix maximum at 1 by 2 comma 1 by 3. What is the given function? It is x³y² into 1 minus x minus y. You can substitute the point in this function. So 1 by 2 whole cube. It is 1 by 8 into it is 1 by 9 and 1 minus 1 by 2 minus 1 by 3. So it is 1 by 72. 8 nines are 72. Inside the LCM is 6. So 6 minus 3 minus 2. However, it is 1 by 6. So 1 by 6 times of 72. 6 2s are 12. 6 7s are 42 plus 1. It is 43. So 1 by 432 is the required maximum value of the given function. In this way, we are completing the problem. I hope you all understand each and every step clearly. Thank you very much. In the next video, I will give some more examples on the maximum minimum.